Thanks, Amanda, and thanks everyone. I'm a little shorter than most people, so I just have to adjust things. So yes, my role in Goulburn Murray Water is Innovation and Business Development Manager, but I'm really here to represent the water industry as a whole through the Intelligent Water Networks program. So Intelligent Water Networks, or IWN as we call it, is a program partnership that's made up of 18 water corporations, Victorian water corporations, Vic Water and also Dell. And the purpose of IWN is to really collaborate and partner and discover new ways in which we can run our businesses and share learnings and share costs about research and development. For those of you who are in the water industry, and I know there's a few water corporations represented tonight, I've seen some names from Southeast Water, City West Water, Central Highlands, Melbourne Water, and I think there's even a Western Water representative here tonight. There's not a lot of money around for us to be exploring really radical technologies and cutting edge technologies. So the IWM provides a really safe space in which we can all invest a set amount of money and all take the shared learnings out of that. So it's a really good program for us to all come together, share our common challenges, but also all experience new technologies and try out new research and development projects. So the current IWN programs we have are big data analytics, it's one of those buzzwords, asset optimization, critical for water corporations because we have some very, very old assets, leak detection, condition assessment, collaboration and knowledge sharing, remote technologies, which is the program that I lead, energy optimization, so renewable energy plays a key part, and then biosolids and resource recovery, and again that's in that energy space. What can we do with those and what energy can we create from that? So I guess some of the other presenters may be in this space. I think there's some data scientists in the room. I'm not a data scientist in any way, shape or form, but really with big data and analytics, for us it's really about understanding the value of information that we can get hold of about our customers, about our assets, about our service, and how we can then make the most informed decisions about what actions to take and what's appropriate to take around our assets. We provide essential services, so we're really heavily regulated. So we can't do anything too high risk. We really need to watch how we maintain our assets. Asset optimization and leak detection condition assessment, that program is really about understanding how we better replace, repair, or remove assets. And if you can imagine sewerage pipes and water pipes that are set underground, they're really difficult to get to. So new technologies are really critical for us to use because there are ways in which we can actually look at those conditions of those assets without having to dig them up, open up the ground, cut off service to customers, and that's a really critical part. So remote technologies is the program that I look at, and that sort of runs across a number of those programs. So what sort of things do we mean by remote technologies? Well, of course, drones come into play, or unmanned vehicles, or remote controlled vehicles, remote mowers, you name it. Anything that's remote controlled, we will pull into that program if we can. If we can find an application for the water industry, we'll use it. But there's some really good trials that we've done recently. We're currently looking at algal bloom monitoring. So this is really a drone, but with a special camera on there that can read the chlorophyll levels in water and can help us predict where we might have some algal blooms. And water quality is a major risk for our industry. So being able to predict patterns of bloom in waterways is a really essential component of what we do. Underwater asset inspections. So, we have to sometimes put divers underwater to look at the footings of major dams or weirs and weir gates, and that's really got a lot of OH&S issues in it. So any technology that we can send underwater to bring us back the footage and the information and data that we need to inform us on that condition of that asset, then the better. So technology plays a really good part in that sort of scenario. Water sampling drones. We actually, there's a lot of manual intervention in testing water. I don't know what the other water corporations do, but you know, we've got water bottles on the end of fishing rods, you know, then we scoop them up in the water and go out in boats. It's a very manual and intensive process. So we really want to look at ways in which we can collect water and test quality, the quality of water through you know, more efficient means. Underground pipe inspection. So we've had trials in the RWM program where we've sent, I think they're called sewer bats, and the guy from Western Water will probably correct me if that's not the right name, where, you know, it's somebody's job in some water corporations to look at hours and hours and hours of CCT footage of the inside of sewerage pipes and underground pipes. It's not a great job to, but it's necessary because we need to know where the cracks are going to occur so that we can take preventative maintenance on them. So technology that we can put down there instead of that, that shortens that time frame by which we can actually measure the condition of the asset is much better for us. And we've had tests of this, I guess they're sort of remote controlled drones, but they're going down one manhole on a tether along to another manhole. They use algorithms, so that's for the data scientists in the room, to tell us where the cracks are that are at a certain condition rating. So that really cuts down the amount of analysis work that we have to do. And this one sounds like a really simple one. Mowing of steep embankments. We've started using remote controlled mowers in the industry, and people might think, well, that doesn't sound very, you know, techie. But, you know, dam embankments are very, very steep. It's a major OH&S issue to get a human being to try and mow something that's at that degree. Often the embankment grass is very, very long and isn't done for many, many years because you don't actually have to check the condition of the batters very often. And so remote controlled vehicles to cut down the OH&S issue is a really good example of where simple technology can make a major difference. Virtual reality and augmented reality. I know other speakers are going to be touching on this as well, and we've really started to dabble in this space. Melbourne Water are a great leader in this space, and I've actually won an award for a virtual reality module, a training module, OH&S training module that they created. And other water corporations, Western Water has recently done a trial using augmented reality through the IWM program. And that's where they can look at the components inside, the impellers inside pump stations, and really understand how that should be operating. And we can use that for training, we can use it for asset inspections, and we can use it for predictive maintenance of those assets. So they're going to play a real part. They're not fully in the industry yet, but that we're really on the verge of being able to explode in that area and start to use that technology. And to me, OH&S is a really critical area. If we can get people being trained through virtual reality, then all the better, especially when our water industry, we've got some very remote areas and very remote assets where people have to get trained up on. And other technologies, 3D printing, satellite monitoring, and I know that Quentin is talking about the satellite monitoring project later, so I'll leave that for him, and weed management. These, again, are major challenges for us. 3D printing, how are we using that? Well, we're looking at the development of asset components. So we're not going to get into the manufacturing industry, but the technologies like 3D printing play a real role in our supply chain costs. You know, if our suppliers of major assets, like foundries, use 3D printing or other alternate methods, and then that will cut down the cost of our assets, and that really cuts down the cost of the water service to customers. Satellite monitoring, again for ground penetration or also water theft, water leakage, that's a critical issue for water corporations. And weed management. Who'd have thought that weeds would be something that really needed a lot of treatment? But it's a major, whereas there's water, there are weeds, and there's a lot of them, and they're pretty stubborn. And herbicidal treatments are not that palatable to a lot of people, to the environment, and to customers. It does play a part in water quality. So if we can look at other ways in which we can remove weeds from our waterways without having to resort to chemicals, and at the moment it's predominantly chemicals, then we will investigate that. So in the IWM we're starting to look at steam treatments for weeds, microwaving of weeds, and also sandblasting of weeds. So any way in which we can clear those waterways in a safe and environmentally friendly manner. Oops. Sorry, just quick fingers there. So just on 3D printing, I just thought I would show you a couple of examples of things that have been 3D printed within our program. The cogs over there on the right, which as you can probably tell is a set of gears, and a set of gears that were needed for a weir component. And what 3D printing's done for us is that it's allowed us to actually produce these components on site and trial and test different asset types. So we'll do many components and prototypes of that before we decide that the right one can go out into production. Traditionally, we would have to have designed it, using CAD, some 3D modelling, sent that off to a manufacturer. It may have come back and said, oh, it's not quite right, it's not quite going to give us what we wanted, let's go back with another design. So being able to bring that in-house in water corporations, and I know a number of the Victorian water corporations are using really simple desktop 3D printers to produce components and prototypes of assets, and really cutting down their cost and really cutting down the time in which they can redesign new components when they're looking at aging infrastructure. And the very shiny, what looks like a shiny fruit bowl there on the left, is actually called a pintle cup. And that pintle cup sits at the bottom of a very large weir gate. So if anyone has a houseboat or a boat that ever travels, goes off onto the waterways, and the weir gates and the lock gates open and allow you to pass through the lock, that pintle cup sits at the bottom of those weir gates, and it really holds the hinge pin on the weir. And we worked with CSIRO over at Lab 22, thank you, I'm almost done, to produce that through their metallic additive manufacturing printers over in Clayton, to see whether or not we could actually get something like that. We only replace them every 10 years, but because of that, you want to be able to redesign assets 10 years on from the last time you did it. Can you use a different material? Can the ferrous metals be a little bit harder? Should it be soft? Should it be hard? So having access to technology like the metallic additive manufacturing printers has also brought some great learnings for us. And these sorts of things bring down the cost of our business. And for me personally, I live in a rural Victorian town. The cost of water for our farmers is a really critical point at the moment. And anything that we can do in our industry to reduce that or sustain that, so that we're not putting those farmers out of business, we will buy into. So even simple things like being able to produce component parts of assets on a desktop printer makes a real big difference to our cost. So that's me. I think I'm about on time, and I know we're going to go to questions at the end, so I'll speak to you later. Thanks.